Hi, good afternoon, and welcome to Grand Rounds. I want to say welcome to Stephen Furmanek, who will be presenting on SIR and SUR's data this afternoon. We've got a great presentation scheduled for everybody, and at this point, I'm going to hand the presentation over to Stephen.
All right, can everyone hear me?
Yes, we can hear you.
Awesome. Let me go to presenter view. All right, is this showing up for everyone now?
It is.
All right, great. Hello, welcome. My name is Stephen Furmanek. I'm a senior biostatistician here at the Infectious Diseases Institute, and also a contributor to our Kentucky Infection Prevention and Training Center. Thomas, unfortunately, is ill today, so he won't be presenting with me. It's just going to be me. And so we're going to talk about the standardized incidence ratios and standardized utilization ratios, and kind of going over in detail what they are and why we use them. Our objectives for this grand rounds are to describe SIRs and SURs and why we use them instead of other metrics, and then to review how they are calculated. So, as many of you all are involved in infection prevention, you all are, of course, tracking hospital-associated infections. So let's imagine a scenario where you have 5 central line associated bloodstream infections during a 12-month period. And during that same time, you have 1,600 device days. So as going by the classical incidence, we would say that you had approximately 3 infections per 1,000 device days. Now, while this is useful for your own facility, there are some disadvantages. Namely, it's really hard to compare a rate at your facility to either other facilities or the national average. So while you can track your rate over time at your facility and you have some internal consistency there, the comparisons would involve a lot of adaptions and changing to adjust for the fact that your device usage might be in like a diversity of wards where you have central lines installed. There may be several different facilities that you have, different facility types even. So that makes incidence hard to use. And you would have to use statistical modeling to account for that. Typically meaning you would have to model the incidence as your outcome and then use those other variables of your facility type to try and make predictions on it. Now, the problem with using incidence rate is that there are implications for it involving statistical distributions, which make them difficult to leverage. The first is that if you have an incidence rate and that's what you're modeling, you could end up with a negative predicted incidence, and that's pretty bad because then that makes no sense, right? Like if you have no infections, that's the lowest you can get. You can't have negative infections. So some of these implications really limit the validity of these models. Also, if it is a rate, then that also comes into account the processes by which rates happen, and then there are lots of assumptions for that type of process too. So I won't get into all of the limitations there. Just know that incidence can be difficult to model. So that's why we might look at incidence ratios instead. So ratios have nice properties for modeling in the sense that they can never go below 0, meaning the problem that we had with normal incidence, we won't have that here. And then rates can also handle adjustments well, and so that each adjustment essentially becomes a multiplier. So if you have twice the number of beds or twice the number of patient days in a ICU compared to my facility, we can use that as a modifier to then, say, we'll adjust for it. So you can a little bit more directly compare by using a rate ratio. However, to make the best comparison, usually you should have a common baseline, because otherwise you would have to make a pairwise comparison for every single rate ratio that you make. So if you wanted to look at the three major hospital systems in Louisville, Kentucky, and look at rates of disease and compare them, then you would have to create pairwise comparisons between each one, as opposed to just coming up with a standardized number. And so when we talk about creating a standardized incidence ratio, what we end up doing is creating a ratio based on the observed number of infections. So this is literally just the number of infections you saw divided by the predicted number of infections. And so you may be asking, well, how are we calculating that predicted number of infections? So in order to do that, we are using what's, as the time of this recording, the 2015 baseline NHSN data. So the NHSN in 2015 essentially used the entire calendar year to provide a baseline for statistical modeling. So using this data, what they did was essentially capture all of the data from anyone contributing and then said, okay, we'll use this to build our models to make predictions. So then for each facility type and each infection type, you could end up with different statistical models that have different weights applied to them that give you different predictions. So the type of infection is typically dictating what type of models used for a standardized incidence ratio. So for example, one-time events such as surgical site infections need to be handled differently than your device-related infections. And that's because surgical site infections, either you get an infection or not based on the surgery, whereas a device-related infection, if you are on a ventilator for 5 days, you have a higher risk of developing a ventilator-associated event compared to if you're on a ventilator for 6 hours. That's why there's different sort of mathematical modeling and machinery going on. So I'm not going to get too involved in kind of what's happening behind the scenes because that would require a much longer presentation. But just know that there are different models that are made for different types of infections. And by using these baseline statistical models, we can then calculate the number of infections. And the CDC actually lists which variables or pieces of data are used when calculated the expected number of cases and also the expected number of device days for the utilization ratio. I have those linked here. They are just some fact sheets that are available from the CDC in the NHSN. But the links there are current as of yesterday. So when we can send this out and then you can access them that way. So as I said, the SIRs are calculated by facility type. So for example, you might have an acute care hospital or a critical access hospital or an inpatient rehab facility or a long-term acute care hospital. So those all will have different calculations for different, meaning there will be different variables used and different methodologies potentially for your incidence ratios. And then they're also calculated by infection type, as I said previously. And so the surgical site infections are based on the procedures and the sort of patient characteristics. For example, it might say like, are they diabetic, or their age or gender might be used in looking at your predictors for surgical site infections. And then your device-associated infections are all going to be based on your facility characteristics. So to highlight some of these differences, if we're looking at CLABSIs in acute care hospitals, it will look at your location. So it'll have if it's a critical care ward, a general ward, a step-down ward, the type of ward where a patient's at in terms of the number of patient days, the facility bed size. So the larger your facilities, it's assumed that you have greater risk. Affiliation with medical schools. So there's actually a gradient there based on the level of medical school, or if you have no affiliation. And then the facility type. So if it's general acute care versus like a veterans hospital or a women and children's hospital, those are all factors that go into the calculation of the predicted number of infections that will show up there. And so if we look at, say, a long-term acute care hospital, they have some similar features, but then some different ones. For example, we have ICU versus ward, so a little bit simpler in terms of the location. but the facility bed size is still accounted for. But then based on the long-term acute care surveys, they factor in the average length of stay, the proportion of admissions on a ventilator, and proportion of admissions on hemodialysis when looking at CLABSI. So interestingly, there is a significant relationship between the proportion of admissions that are on ventilators and central line associated bloodstream infections. So very interesting finding there that you would think those would be independent, but evidently they are not. Interestingly, you could also have what's called an intercept-only model. So in the critical access hospital for CLABSIs, there are actually no variables that are used. It's an intercept only, meaning that there's essentially no adjustment. And the reason for that was when they were doing the statistical modeling, they found nothing to be predictive in terms of the location or bed size or things like that. None of those factors were predictive of increased risk or decreased risk. So it uses just the baseline. You're essentially comparing the critical access rates to the whole 2015 cohort without any sort of adjustment. So then one of the things that you may think about is when you're entering your NHSN data, part of the reason why you enter those details is because those pieces are used to calculate your SIRs. For example, the CMS looks at SIRs by different units, right? Like they'll look at step-down units and general ward and ICUs separately. And so you are actually calculating SIRs for different wards. And then to get your facility level, you're aggregating those together and just adding them all up. So if we return to our previous example that we had, let's say that, and this is totally making up numbers, right? The predicted number of infections for CLABSI during this time was 6.54. So if we take our observed number of infections, which was 5 from earlier, and then our predicted number of infections, 6.54, that gives us an SIR of 0.764. So 0.764, how do we interpret that number? Well, the first thing to consider is that because SIRs are based on an estimated number, we should use confidence intervals because there's a degree of uncertainty around the SIR. So again, this is a made-up confidence interval, but let's say that the confidence interval calculated was 0.764, and it goes from 0.711 to 0.789. So when we interpret that confidence interval and our base SIR, how do we know if that's good or bad? So if our observed and expected number of infections, expected being the predicted number of infections, are the same, your standardized incidence ratio is going to equal 1. So you can use this as kind of a threshold value alongside your confidence interval. And as a reminder, our confidence interval will show greater certainty than a larger confidence interval. So if your confidence interval spans a very large number, that means typically you had very few patient days in that area, or you had your facility is small, or the estimate could be potentially unstable. So a standardized incidence ratio, being a ratio, is going to go from 0 to infinity. So going back to what we had approximately, this isn't an exact number, but if you look at this green arrow going back and forth, that would represent, roughly our standardized incidence ratio that we had calculated for our CLABSI over the past year. So in this case, we are doing better than the baseline because we are completely lower than 1 for our confidence interval. Now, the opposite's also true. We could be doing worse than baseline if our lower bound of the confidence interval is above 1. So the last thing to consider would be we have not a significant difference than baseline. So this could happen because you have a very wide confidence interval, or it could happen because your SIR is very close to the national average. So in this case, the confidence interval will contain 1. So it'll usually be 0 point something to greater than 1. So based on our example that we had, if we have a standardized incidence ratio, 95% confidence interval of 7.64 and ranging from 7.1 or 0.711, excuse me, to 0.789, we can interpret that we have a statistically significant lower infection rate than the national average for our CLABSI. And this is accounting advantages of SIRs is that we can make easy comparisons to a national average because, again, if we look at 1.0 as that baseline, then we can say we're either above or below. And we can also make comparisons to facilities of the same class and type. So, for example, we could, let's say we're a critical access hospital, we could look at other critical access hospitals and see how we shape up by comparing the confidence intervals. Again, there is a little bit of caution you should advise there. But it does allow you to compare to other facilities. And you can even also look at your SIRs and track them over time, similarly to if you just had incidence rates. Because we're using the same baseline and that baseline isn't changing, that gives us a common reference point for which we can keep evaluating our new aggregate at the state or national level. So, for example, remember that the even smaller level than facility. Sorry, can you all still hear me? I just got a message that my connection was unstable. I'm going to continue unless otherwise. So, one advantage is that the SIRs can be aggregated at higher levels. So within the facility, remember, you can have SIRs for each individual ward. But then you could take your facility SIRs and aggregate them at the state level. You could take your state SIRs and aggregate them at the national level. So if you look at the data available from the NHSN, the HII data has both national and state SIRs available that you can look at. And the way that it works is that it's still taking those predicted numbers. So if nationally there's 1 million infections over the course of a year, what it will do is it will look at each of those wards and then say, okay, based on the data that we have reported to us, each of these wards has this much predicted, and then it just adds them all up. So you just keep adding them up and creating sort of larger aggregates as you get up to the national level. So it's very, very easy to aggregate, although it sounds complicated. And there are a couple quirks about the standardized incidence ratio. So if your expected number of infections is less than 1, an SIR will not be calculated at all. So an example of this is if you look at the 2022 NHSN acute care hospital reports, Guam only has 2 reporting hospitals. And so pretty much all of their stuff has no standardized incidence ratio. When you pull your data for your institution from the NHSN, and you look by ward, if you've submitted it that way, then oftentimes you may not have enough infections to get an SIR if your predicted number of infections is low. And then if your observed number of infections is 0, then a 95% confidence interval lower bound won't be calculated. And that's because you're already as low as you can go. You can't go lower than 0. So you only have an upper bound in that case. So related to a standardized utilization rate or to the standardized infection rate is the standardized utilization rate, or the SUR. And so it is using a similar formula, but we're comparing the utilization of devices as opposed to the number of infections. So in this case, we're looking at an observed number of device days divided by a predicted number of device days. And it uses essentially the same methodologic principles as calculating SIRs. So it's using the 2015 baseline data, and it's similarly calculating based on those factors the number of device days that it predicts you'll have based on the number of patient days. So if you have, it'll come up with a predicted probability, you multiply that by your number of patient days, and that's how you get your predicted number of device days. The interpretations from your standardized utilization rate are pretty much the exact same as they would be for an SIR. So once again, you have 0 to infinity. And if you're doing better than baseline, that means you have fewer device days than the national average. If you're doing worse than baseline, that means you have more device days. So that would be if your SUR is entirely greater than 1 for the confidence interval. And in this case, it would be entirely less than 1 for the confidence interval. And then once again, you could have an SUR that's not significantly different than the baseline, and that would be if your confidence interval contains 1. Similarly, you can compare it to other facilities as well. Similar to SIRs, if the expected number of device days is less than 1 for whatever reason, an SUR won't be calculated at all. And then if the number of device days is 0, similarly, it will also not calculate a lower bound. However, since device days usually are much more frequent than infections in terms of device utilization, these considerations are much less frequently met. So moving to some points for discussion, to kind of conclude, SIRs and SURs provide a robust framework to adjust for your facility's demographics. They allow you to compare yourself to other facilities, to your state, to the national average, and they even allow you to compare within units. So here at Norton, we are able to actually look at SIRs by unit. It really depends on the data that you put in, determines kind of the data that you get out. In terms of if you have quality reporting in, then you can get quality reporting out. One thing to consider, though, is that the 2015 baseline is almost 10 years old. So, next year it will be 10 years old. And the CDC has stated in their considerations that how often a baseline should be updated, there's no real standard set. Previously, standards were updated much more frequently before the 2015 baseline kind of standardized everything. There were different baselines used for different infections. So the 2015 baseline simplified the process quite a bit. The problem, though, is that it is fairly old. And some of this is my opinion as well. So don't just come out of this thinking like all of our data sucks because we're using a baseline that's 10 years old. Please don't make that conclusion. But the thing to consider is that we did just go through a pandemic, which has potentially drastically changed device utilization or infection rates. And so a new baseline will likely be calculated pretty soon as healthcare facilities start to reapproach a new normal in the post-pandemic landscape. So I believe originally the CDC was looking at using 2020 for calculating a new baseline. And obviously, since that's when the pandemic started, that would not be a very good year to make a new baseline. Interestingly, if you think about it from a statistical standpoint, a higher infection rate and higher device utilization rate would actually make subsequent years look better, so to speak, because if your baseline was very high, then everything will look better. But it's not really appropriate to use a higher baseline to compare the following years because if you look at a time of like emergency and great shifts in the way that care was being provided, then it's not really a valid comparator. So as I said, we'll probably see a new baseline come out, in the next couple of years. And then one last point for discussion that I think has some interesting implications. The reporting isn't always mandated by the state, by the federal government, or by CMS. So in Kentucky, there is a state mandate to report to the NHSN. And so since the baseline is all entirely decided by who has actually reported, it is a good thing for us to have everyone report because then we can more effectively contribute to whenever future baseline comes in. And so, for example, if there's no mandate, then there is not as much incentive if you are a facility with higher SIRs, because you could kind of have facilities cherry pick what they want to present. So, for example, if you look at CLABSI in unmandated states, all of their SIRs are less than 1. And generally, they have the best SIRs if you look at the 2022 NHSN data. So that could be because they have a selection bias that is sort of preventing their data from really being comparable. So that's why you should take some comparisons between facilities. That way, looking at SIRs with a little bit of a grain of salt, because there are factors to consider there. So yeah, that ends the presentation. If are there any questions or comments or points for discussion that you all have encountered with SIRs that you want to discuss?
I don't, Stephen. I do echo, though, what you were saying about the importance of putting information into NHSN to help to develop strong benchmarks going forward is going to be very important.
All righty. Well, if there's no other questions, feel free to, if you don't want to share them here, feel free to contact me at my email. I will send this presentation to Chelsea so she can send it out to you all. So I guess that is everything. So you all have a happy Valentine's Day and good rest of the day.
Thanks so much, Stephen.
Thank you.